Hello, Regis students. How are you? So I've had a couple of fails with my audio recorder, so let's hope this is the good one here. So we're in recursion on lesson 10, and the way that it's set up, I'm having you show in the menu over here, is that these training exercises are all to teach you on how recursion does a number of different calls. So the data structure, you can think of it is called a stack, or you think of all those cubes we had stacked earlier. But I'm going to show you, starting with a mathematic example, on what a call means and how it breaks down work into little chunks. So we're going to go through that, and then we'll go through linear, advanced, binary recursion, and look at some trees. So a factorial is a way of taking a number by itself with using the apostrophe, and then you subtract a value of 1, and then a value, the next higher order number, then the next higher order number, as you see here, 1, 2, 3, and then you create this mathematical formula. Well, when you run this in a calculator, it goes boom, it gives you 120. Okay, but from a recursion standpoint, is you can think of it as, I'm going to do 5 first, and then I'll do 4, and then I'll do 3, then I'll do 2, then I'll do 1, and then I'll put all of my components together. So what you can think of is that when you're solving a big problem, I have a lot of data to find. Well, I'm going to break up the problem into smaller steps. So that is what the essence of recursion is. And so this trace factorial, there's going to see I have created a nice little picture for you down here, but showing you how you're going to be able to do the work for 4 to 3 to 2 to 1 in sequence. And although this is sequential, remember from earlier that recursion it will actually create a number of different calls at once. When the formula is up here, these might be a little dense, but they're all very simple, just if-then statements, and I tried to label them out for you nicely, and then some complex print statements. But the whole point is when you look at this tree, all right? So when you call a recursion function, at its utmost basic is to do a factorial 4, it's going to place 4 calls, it's going to provide 4 returns, which all then get put together. Well, in this case, it was summing them. So that is the essence of recursion. Now, some of the other visuals are to connect from earlier, like with our grids. And so when we have an array, whether it's any type of row or column, whether it's a 1D array, which would be a 1D array is a linear vector, or 2D, or even a 3D. What I want you to understand is that for rows and columns, as we're putting these grids together, all right, you have a little example of a telephone pad, all right? And so what these examples are going to show you is, first off, what a grid is, how we make the grid, some of the code for that. But we could start a search at A to go and find F, or we could start a search at I to go and find F, or we could start at both A and I to go and find F. And so that is the essence of what we're working towards, you having to be able to build some mastery in, so you'll know when to come and get this in the future. Now, the other example that's just like the factorial, the linear example, okay, is the linear adds in this idea of heads and tail that you will read about. But if you just have this list here, so that this is a list, and values are 1, 2, 3, 4. Okay. Well, the head is on the left-hand side, the tail is on the right-hand side, and we could combine all of them together by adding across heads and tails. So we could take 1 plus 4, and then it would do 2 plus 3, and then that's how it would equal 10. So it broke down into 2 calls to be able to add the values together, add the head and the sum with the tail together. So you need to get your brain going, that you might not. That's why I gave you all these visuals, so that you can help understand and you can see these items working together. Now the advanced, I added a few exercises here, but they all work pretty easy. What I want you to then see is when you're doing, like, here's a typical recursion exercise when you're trying to go find, is there a value in a list? And so but what you can quickly think about is that you might be searching for that value, but it could be in, a 800 table database, and then that makes it a lot more challenging. But the other item that recursion is used for is helping to aggregate information. And so that's why I've added in some patterns here, so you can see when we're going to be combining information that is found in whatever variant order is put together. So as a refresher, all of these examples here are not to make your life harder, but they are all very strictly formatted, so if you go and use them to help generate code later, you have a very solid process for doing that. And because still a lot of the AI tools generate some, they can make things much more complicated. This is clean code, so I want it to look like this. All right, now the last search is the binary search, which is typical, like this would be your next computing class challenge where you have to go write this algorithm yourself. So you got to go sit and figure it out, and it's a recursive exercise. And so like the hyperplane that we saw earlier, it is separating the data somehow between a halfway point, high or low, and then you need to find a subset of data within it. And so that's the essence of these exercises and how recursion is working. I'll take you through the labs here, but I hope that you're enjoying this new method here. And the other code books will be done, in just a few more days. So thank you so much, and let's hope this worked.